Hi, everybody. Welcome to Muddy Run Park. I know we've been trying this for 4 or 5 times, and I think we've now made the connection. I'd like to welcome you all. You're live at the Muddy Run Observatory. This is a live stream. You're either watching us on our Muddy Run Observatory webpage, or you're going to YouTube and you're looking for Muddy Run Observatory because it's streaming through that area. So I'd like to welcome you, and we're actually kind of psyched here because over the last couple of months, we've done some upgrading to our observatory, and that would be our telescope. Telescopes are amazing instruments. They have to be fine-tuned, and after 3 years of all of us learning how to use the scope, we decided it was time to give it a little bit of fine-tuning. So that's our observatory director in the background there. His name is Al Ryan. He's trying to prepare for us a possible video shoot, but I'm going to warn everybody. I just looked out the window here. We have a very smeary sky, and I think maybe one star and part of a crescent moon. So we'll have to see if the sky really does work with us. I'm going to try things. I've got Dan actually watching me on another monitor in the background to make sure that everything works here. What I'm going to do is I'm going to switch to another pad, and I'm going to share a little bit of a screen with you guys, so give me a second. It has to give me the 3, 2, 1. Okay, and what I have here is our, do I have it, Dan? I believe so. So what we have here is our planets from last year. We were at the Sky Observatory, and I'm going to turn this one off here for a second. We were at the Sky Observatory last year, and there are 2 things we were looking at in particular. I'm going to do the planet report tonight. Denise couldn't make it here with us this evening. In fact, I think I should dedicate the show to Denise because Denise, her mom recently passed away. So that's why she won't be here for the planet report for us tonight. But if you look at the screen, you can see we've got Saturn over here and Jupiter over there. But you're going to notice they are, oh wait, Dan? I think I'm only highlighting my screen. I've got 2 planets side by side. I've got Saturn here. I've got Jupiter over there. But this is last year. This is right about our star festival. In fact, we're checking it out. Sorry, technical flaw. You should see it here, right? Should be up there. Well, I'll keep talking even though I don't know if I'm really coming through. And when your visual comes up, it'll probably be there shortly. I'm looking at a visual of Saturn and Jupiter. Now I believe I'm going to be up there. Okay, so now we're talking. A lot of you were out here with us last year for our Sky and Star Festival. We had an amazing night. And if you remember, look at the bottom of the screen here, everybody. I have us set up for Friday, August 23rd, 2019. If you take a look at where Saturn is, dead screen now, center, and take a look at where Jupiter is, if I'm not mistaken, last year we were able to put 3 fists at arm's length between those 2. So let's do a little bit of a measurement, see if it works. I have Saturn selected. I'm going to measure the distance from it, and I'm going to take it over to Jupiter. And it's hard to see, but if you look right on the planet's surface, you can actually see they were 29 degrees apart. And that was last year at this time. Well, planets don't sit still. They actually move around in their orbits. Think about this now for a second. Which one you think will move further, Saturn or Jupiter? It's a trick question. Which one is further out? Those are the ones that appear to move slower. So if you look at Saturn, it's over there above the shoulder of Sagittarius. And if you look at Jupiter, it's over inside the constellation of Scorpio the Scorpion. That was 1 year ago. Now Jupiter travels around the sun much quicker than Saturn. I think Saturn's almost 29 years. Jupiter's 10 or 11 years to get around the sun. So Let's go 1 year forward and take a look at tonight. Now, I kind of promised this to you all last year. I said, take a look at Jupiter, take a look at Saturn, because by next year, you'll be able to see them get a lot closer. So if you're near a clear sky right now, and you want to check this out, go outside, extend your arm to arm's length, and make a fist. And that fist should be about 10-degree angle in the sky. Well, let's take a look now at the computer calculations. From Saturn to Jupiter, again, it's right on the planet, but you see it's just about 8 degrees, almost 9 degrees of separation. I'll be honest, everybody, this is some of the coolest things to look for. Once you learn looking around the nighttime sky, you start to notice all of the motion that's around there too. So Saturn and Jupiter were coming closer and closer together. Let's go in the future and see what's going to happen in the next couple months. So what I've done is I've centered Saturn. I'm going to switch over my time frame to days, and I'm just going to go day by day forward. So we're in August. Now we're coming up on to September. Notice how Saturn and Jupiter look like they're getting closer. Now we're coming into October. Yeah, you see the moon running by. It's going to run by about once every month there. Take a look at this now. End of October. So let's do October 31st, Halloween. So how far are they apart now? Well, if you look at Saturn and we try to measure the distance from Saturn, let's see. Saturn, measure it from Jupiter. So it's only going to be 5 degrees apart, and that's going to be on Halloween night. That's the same as holding your arm out at arm's length and putting 3 fingers up, and that would be about a 5 degree of separation. Okay, let's see if we can go a little bit further. Now we're going to lose them eventually. They'll go below the horizon, but this is October. So here we go. Now we're going through November. And when planets get real close together in the sky, we call it a planetary conjunction. So I guess the closest we're going to see this conjunction is going to be the very beginning of December, because after that, we'll lose them from our sky slowly after. But when we go all the way into December, you're only talking an angle of distance between the two, measure it, and we're talking 1 degree. 1 degree apart. That's 1 pinky finger separating the two. So those of you who are astronomers, we have some neat sights coming up. If they're only 1 degree apart, that means in our lowest field of view in our telescopes, we might actually be able to catch both of them. So those two are our most obvious planets. They're up here tonight. And I hope that you guys can get out in your own backyard and take a look for them also. So let me come back over here to our big screen. Okay, thank you. Boy, does it help to have technology assistants standing by. Okay, so are we set to do this like we practiced earlier? Do I have Mr. Moonman in back of me? He should be right there. He should be right there in camera. Mr. Moonman, are you back there for us? Hello? Up, let's see. He just appeared. So behind me, everybody, is Bill Green. Now, we have to do this like the Democratic Convention. I can't get near him without a mask, and he can't get near me without a mask. So let me introduce him first, and then I'll go in the back, and I'll let him come up forward here. About, I'd say 2 years ago, I was down on South Street, met a couple gentlemen out there in white suits, and they were right at 4th and South, and they had a telescope outside, and they were asking people to stop over and see the moon. I asked them if I could help one night. So I went down, and the moon men have a habit of putting on a white jacket. It kind of sets the mode for them on South Street. Remember, South Street's a big partying place. And what we did is we stood on the street all night, inviting people to come by and take a look at the moon. At that time, I had turned to Bill and I had said to him, I feel like John Dobson. And I don't think he knew who he was at the time. John Dobson was a astronomer who used to take astronomy to the streets in San Francisco. In fact, those of you who have a Dob telescope, he made a very simple crate to move his telescope around on, and we now call that a Dobsonian mount. So anyhow, I had a great time when I was down on South Street. In fact, Bill made me an official Philadelphia Moon Man. And Bill and his brother, Brendan, they last summer went on a tour of European observatories. Now you might wonder, what gets people interested in doing that? Well, Bill's an optical technician. He works with optics all the time. and he thought it'd be a great idea. He's a bicyclist, and so is his brother, and they thought that they would bicycle across Europe and take a look at some of the most amazing optical instruments that were built back in the past. So what I asked Bill to do tonight is to come to us and share a little bit of that trip. And here's why. Here's what our goal is. Al has given us a good suggestion. What we'd like to do starting in October is we'd like to see if we can Zoom some of you in. Some of you have backyard observatories. Some of you have piers mounted outside of your house. So what we were thinking is to highlight some of these amateur astronomers in the area. If you have a small observatory in your backyard, or if you have a permanently mounted pier, or if you happen to have a setup for your telescope that you do on a continual basis and you'd like to zoom in live with us, we'd like to include you as part of our Muddy Run presentations. So tonight, I'm going to turn this over to Bill Green because he's going to give a little bit of tour of some observatories. Now, when you're looking at these observatories, they're not going to be anything like the backyard observatories some of us have. But I must admit, when you're building your own backyard observatory, I think some of that motivation comes from looking at some of the larger observatories around us. Because what you're really trying to do is create that on a very small scale. So right now, I'll ask Al to step aside. I'm going to mask up also. And I'd like to introduce everybody to William Green, Bill Green, our Philly Moon Men. Thanks, Bill.
Hello, everyone. Hello, team. Hello, world of astronomers. I'm Bill Green, one of the Philly Moon Men. I am an optical engineer working in Old City on LED lighting. So one thing that telescopes and astronomy show us how to do is return to darker night skies in our cities. We're reaching an important turnover point in history where now just a little over half of humanity lives their lives out in cities and in these light polluted places. So although I'm going to give you a little taste of the observatories of Berlin long ago, what we'll find is that more and more of the evidence that we live in a universe is disappearing. I'll bring up a little bit of a slideshow here. Again, we are the Philly Moon Men. We are your local sidewalk astronomers. We are bringing evidence of the universe out to the streets, out to people who have maybe never looked at a telescope before. And we are showing people, possibly for the first time in their whole lives, just exactly what they're missing. So here's a little bit of our setup back on South Street. And around May of 2019, we decided this wasn't enough for us. We needed to go bigger and better. So we put it all on the line. We quit our jobs. We got a pair of bicycles and we shoved off for Europe. Around that time, we were talking with Al Nagler and David Nagler of Teleview Optics, and they have a soft spot for telescopes and bicycles. So they were able to find a telescope on loan that we traveled with. So all of the miles that we went from Rome to Denmark were traveled with a telescope TV76 3-inch refractor in tow. And that was about, that telescope, the tripod and tube combined was more weight than all of our rest of our luggage. In many ways, the most important item with us. Here is the Philly Moon Men meeting up with a couple of Germans in front of the Duomo in Florence. Florence is, of course, an important city for astronomy because it was for a short time the dwelling place and also the final resting place of the astronomer Galileo. So here we are tonight, set up with our telescope, showing people the Galilean satellites, the 4 moons that proved we live in a heliocentric solar system. And people walking by through this plaza could stumble into the same proof that Galileo stumbled into all that time ago in the same time, setting, and place. And here we are in Berlin with our bicycle bags in tow. This is Brendan over on the left, over on the right, and we have our flag there, our moon flag that we carried all the way from Philadelphia all the way to Berlin. This is us setting up in the Lustgarten. We were having these beautiful views of Saturn and Jupiter that Ted was telling us about all summer long. So we were able to put the solar system on display for a few Berliners. Now, before we showed up in each city, we would try to reach out to astronomers in the area to spread this idea of sidewalk astronomy. We all have those amazing backyard observatories, but one of the most difficult things is to share astronomy with people that maybe aren't able to access it, or maybe aren't even aware that it's lurking in their own backyard. So a few hours after we set up the telescope, people would wander over, and always they have questions. Always, why here in the city? Is there something special about the sky tonight? And you and I know that there's always something special about the sky if you're able to share it with someone. This is one of our astrophotographer friends setting up his equatorial mount. We had an 8-inch Celestron Schmidt-Cassegrain set up and tracking the entire night. So we had 2 telescopes on full duty, enormous crowds. You know, I look back on all of these memories and I think, oh my gosh, they're not social distancing. They're not wearing any masks. But it's nice to flash back to those times, the world where we were able to share an eyepiece all together. To think that so many people could look through the same lens and get the photons we're collecting from hundreds of millions of miles away. To share a little fact about the planets and to make people feel a little more at home on planet Earth. Here we are in Alexanderplatz, which is one of the most highly trafficked public squares in all of Berlin. And this is another night where we were simply bringing people over to the telescope all night, made a few friends, and of course, you can see in this picture, the public lighting situation is critical. You have these very bright, unshielded fixtures. These places where people certainly were going about their business 2 centuries ago. Since the advent of electric lighting, the universe has been blanketed underneath our city's light pollution. And so what we found is in Philadelphia and cities all over the world, people are feeling more and more disconnected from the night sky. This personally is one of my favorite pictures because if you take a look in the background, you can actually see Saturn in the picture, which in this case is just a shoe and apparel store. Well, we couldn't go to Berlin without seeing a few telescopes. And this is a picture here of what's called the Great Refractor, which is the largest pointable telescope in the world. I'll try to flip through a couple of these slides here to give you a sense of the scale. This was a telescope so large that it was really meant to demonstrate that the Germans were capable of building a cannon this size. This is over at what's called the Eichenholz Observatory, where Einstein gave some of his groundbreaking lectures on relativity. This is actually in the building below his lectures, his PhD dissertation was given. So you can see the gear system on this. You can see the absolutely massive structure. It takes 4 people to operate this telescope, 4 people working simultaneously at different stations. And you can imagine standing in the center there. It really wasn't such a useful device, but it did achieve its purpose of proving that you could build just an overwhelmingly large telescope. Well, when we arrived in Berlin, we quickly realized that there was something fated about our location. We were about a 7-minute walk away from the location of the Berlin Observatory, where the planet Neptune was discovered. The planet Neptune is way out there. Since its discovery in the mid-19th century, it's barely completed 1 orbit around the sun. And 7 minutes later from our Airbnb, we were at the very spot where it was discovered. And this to me says a lot about the state of light pollution on our planet. To say that the dimmest planet in the solar system was discovered in the center of what is now one of Germany's most light polluted cities, one of its most densely populated centers, that's really incredible. 150 years ago, you could stand in the same spot and see the Milky Way. I don't have a picture to share with you of this because when we actually showed up there, there was no observatory. It had been moved to Potsdam back in the 1950s, of course, due to light pollution. There was no evidence that an observatory had ever been there. And from that location, there was some stadium light pouring down on us to the point where we could barely even see Saturn. So in the birthplace of the planet Neptune, the evidence that we live in a universe, that we even live inside a solar system, rapidly disappearing. And the importance of bringing those reminders into the center of our cities, back from the islands of deserts of the world. We need to be doing this outreach really in the cores where people can't see the sky. But we weren't going to settle there. We had to go find a rooftop, and our hosts for the evening brought us up to the roof, where we took a lovely group photo of everyone else in that hostel. I think that we had 4 out of the 6 people here, their very first time through a telescope. So all over the world, this is a running theme. Not something a lot of people have experience with when you start to look at the numbers. We weren't going to settle at that though. We wanted to have a chance to see some really big telescopes. So the next day we were on our bikes out to Potsdam, where they moved all the big telescopes after it was too light polluted, too bright in Berlin to use them anymore. The Potsdam Astrophysical Center is now one of the foremost research institutions for climate change. So not just taking a look further out, but taking a more critical look further in at our own activities on Earth and the impact we're having. All right, well, here we are. Again, these are all called the Great Refractor, right? And this is a telescope that back in the 1950s was still making some very important observations on Mars. I love looking down the tube of a refractor like this. You start to get the scale of things, of what a long focal length, what an intense magnification, and truly how patient you need to be in order to get that one lucky shot that could make a critical research finding, that one photo plate that just seems to come out perfect. Here we are out in Muddy Run, experiencing some cloudy skies, but that doesn't mean we won't keep coming back out here until we can see something special. To give you an idea of scale from the outside, here is that same dome compared to, in the front here, my bicycle. And the classic architecture along these walls, the arched windows, reminded me of being all the way back in Rome, looking at the Pantheon, these temples to the gods of the sky. In a funny way, telescopes seem to pay respect to that. These large airy domes where we spend the whole night just trying to get one look at a little deeper into the heavens. But there was more over there in Potsdam. There was actually the Einstein Observatory. This is a very historically important structure, even though it never made a scientific discovery. There's a very special solar telescope inside there called a heliostat, and their goal was to measure something called the gravitational redshift from the sun. So this was the idea that Einstein predicted. As light from the sun gets sucked into the gravitational well of the Earth, that hydrogen spectrum would actually redshift just a tiny bit compared to if you're looking at the hydrogen spectrum on Earth. What they realized after they built this observatory was that the effect was hundreds of times smaller than they were prepared to measure. And although they never made any conclusive discoveries here, it's still remembered as the Einstein Observatory, the first attempt to measure the gravitational redshift. And here's where I'll close. This is Michael Quaid up in Denmark. We've left Berlin now. We've gone further north and into the northern skies. We're actually so far north here that during the summer there's only a few hours of twilight each night. So we get to this point where the sky never really gets dark, even at 2, 3 in the morning. And by 3:30, 4 o'clock, you can already see twilight from the next day, dawn from the next day coming up, which is why they had their solar observatory set up. On the right, their white light solar filters, and on the left, they actually had a hydrogen alpha filter. And these pieces of heavy equipment were just set up in a small town of about 1,000 people. Michael Quaid is the local astronomer there. He is in part supported by the Danish government and by the University of Copenhagen for his work. He was able to host me for the night in an absolutely incredible personal observatory. And they really have a handle on light pollution and astronomy out there. The connection to the stars and nature is something unlike what I've seen in a lot of places in the United States. And even a shout out to lighting design out there. In the background, you can see a fully shielded fixture. So the International Dark Sky Association would be pretty happy about this. Now, what I've given you today is just a small taste of all the adventures that we had in 90 days of travel throughout Europe. And what I'm excited to announce right now is that within the next week or two, we are relaunching phillymoonmen.org, where we will be revisiting and republishing all of our adventures beginning to end, day by day.
Oh, cool.
So please tune in for that. In the meantime, check us out on Instagram, check us out on Twitter, Philly Moon Men. Keep an eye out for our website to come soon. We are reinventing ourselves in this digital age where we can't share an eyepiece. We're working on social distance astronomy programming right within the city where people need it most. And with that, I'd like to say thank you, Ted. Thank you, Dan. Thank you, Al.
Wait, don't stop sharing.
And I'll leave with just one picture of what our social distance astronomy looks like. So we had a couple of people out. We had 5, 6 telescopes, Max Sutov Cassegrain set up, and the same way that we always have, people came right over. We Lysoled these telescopes down. We made sure they were squeaky clean. And after that, they were ready to go. People were picking it up in about a half hour. So every time the moon goes through its first quarter, we're trying to hold these classes. We're hoping that we can train sidewalk astronomers all over the city for a new generation, a new audience of astronomers, and to help teach people how they can create darker skies in their own neighborhood. So thanks so much for listening, guys. I'm going to turn things back over to Ted, and we're going to try to catch a look at the sky.
Bill, go ahead and mask up. All right. Thank you very much. Good job, Bill. Thank you. All right. I'm going to leave the screen up here for a second, and I'm going to bring Dan McCormick in. Dan's our technical assistant here, and what we're going to do is a little bit of a segment to close out tonight called Rocket Science. Dan, come on in so they can see you. Perfect.
Well, hello everybody, and welcome to the 22 August 2020 virtual Muddy Run Observatory. This is Dave Walker, Secretary of the Rittenhouse Astronomical Society, presenting the Rocket Report for It's Not Rocket Science, except when it is. This month's big news is the return of the Endeavour capsule, the first SpaceX Crew Dragon capsule to carry humans up and back from the International Space Station. Doug Hurley and Bob Behnken returned to Earth, the sea, after 2 months in orbit aboard the space station. This was the final certification test, and now the Crew Dragon is ready to carry crews to and from the space station as part of NASA's Commercial Crew Transport project. Of course, we got to have the clips.
As our views here of the capsule cycle through, we'll be able to see what their screens look like. There we go. So there in the center screen, we actually have the ground tracking map. As you can see there, actually,
a glimpse of that
That's the
WB-57.
WB-57 tracking aircraft. And here's the splashdown.
Splashdown.
as you can see on your screen, we have visual confirmation for splashdown.
SpaceX copies and concurs. We see splashdown and mains cut.
Dragon Endeavour has returned home. NASA astronauts Bob and Doug.
To the SpaceX and NASA teams, welcome back to Planet Earth, and thanks for flying SpaceX.
That WB-57, NASA has a pair of them. They were used to track the Great American Eclipse in August of 2017. Just a quick bit of trivia there. The landing site was the first time we ever landed a capsule or anything in the Gulf of Mexico, just off the coast of Pensacola. The little red X's were potential landing sites, and we can see the hurricane tracking for an offshore hurricane that might have been a problem. It wasn't. Welcome home, crew. The Dragon will be returning to Kennedy Space Center by ship for processing, and Bob and Doug were flown from the ship Go Navigator, the SpaceX recovery vessel, to the Johnson Space Center and Cruise Center in Houston, Texas. Well, with certification done, October skies are here again. The first official mission, Crew Mission 1, is set to go off in late August 2020, carrying a full complement of 4 astronauts, 3 from the United States and 1 from the Japanese Space Agency. Hopefully more on that later, but here's a picture of our fine crew in their crew patch. A little further south, an Ariane 5 rocket lifted off successfully from Kourou, French Guiana, as part of the European Space Agency's launch efforts, a significant achievement given the restrictions placed on spaceflight preparation by the current COVID pandemic. Mission Ariane 253 took communication to Earth observation satellites in orbit. It also carried this nifty little space tug, Mission Extension Vehicle 2, built by Northrop Grumman. MEV-2 latches onto an orbiting satellite where it will adjust its orbit until they get it right where they want it, usually moving it to a better, higher, or lower orbit, or just sending it into a parking orbit so it's out of the way in case it's wearing out. It can then undock and move to another client vehicle to adjust its orbit as desired. A pretty neat bit of technology. This is the second one, and we'll probably be seeing the use of more of these craft in the future. Some of them may even be able to refuel expensive high-altitude geostationary and geosynchronous satellites. Let's head out into the solar system. What could be more exciting than searching for life on other worlds? That's the big question, and that's what Europa Clipper is designed to do. Scheduled to launch in 2024 on a Space Launch System heavy launcher, it will take a 4-year journey to Jupiter to study the moon Europa and search for life-sustaining conditions on this icy body, one of the 2 giant moons in the solar system that we know have water, ice on them, and possibly conditions for life. The other, of course, being Enceladus around Saturn. Here we see the little craft, well, not so little, tucked into the nose cone of the giant Saturn-sized SLS launcher. This is a pretty advanced mission here. It could launch on other vehicles like a United Launch Alliance Vulcan upcoming rocket or Falcon Heavy, but they don't have the power of the SLS, and instead of taking a direct course to Jupiter, would have to take a fly through the inner solar system, getting gravity assist from the inner planets, greatly extending the journey time. But this may be what happened because testing showed some incompatible vibrations that may end up replanning this long-awaited mission. SpaceX has successfully reflown one of its Falcon boosters. It's going for 10 reuses as part of its proof of concept. Virgin Galactic, still working on their ship, but let's get to the outer planets again with the Ingenuity Mars helicopter tucked away inside its transport vessel along with the Perseverance rover. It's begun charging its batteries for its mission later this year. And back to Earth. The giant rocket, Omega, has been canceled. ATK and Northrop Grumman failed to get a U.S. Air Force contract, and now the future of this rocket is over. Without a contract, there's no point in developing it. I know this has been a very short rocket report, but it's been a very busy week. I'm hoping to have more in-depth coverage for everyone later. And for now, keep looking up.
Well, thank you very much, Dave, for sharing that with us. Let me stop my screen share. Well, we've come to the end of the night. And the reason we're at the end of the night is because we've been working diligently in the background. You can see that's Al up there, our observatory director. And Al was going to be giving us a beautiful view of Jupiter. Problem is, he just got the camera ready and Jupiter is gone from our sky. We have absolutely nothing in the sky. So I believe that's going to end our presentation then this evening. I'm going to sign us off. If our members who are on Zoom in the background want to stay on, I can talk with you guys for a bit and get some feedback on how do we improve this for the future. So right there, I'm so glad we had this time together just to have a laugh and share some knowledge. Seems we just get started, and before you know it, comes the time we have to say goodbye. So signing off from Muddy Run.